how this supposed supercontinent that was, in existence, surrounded by what, apparently there were no deep oceans on the ancient Earth, only shallow seas. The textbooks say that. And what I was trying to draw attention to before was the movement of India. And if I go back, and you'll see this again. So we're now going backwards in time, I think, and you'll see, I think. Sorry, no, we're coming forwards in time. I do apologise, because this is millions of years ago. And India is here. Look, this is India, and then it's kind of meant to float around. It's broken off the coast of Africa, and then as we come to modern times, it just shoots up and crashes into, the sort of Eurasian continent, and that's allegedly what created the Himalayas, as I think you mentioned, Ross. So, if you start to look at this and start to look at what is meant to have disappeared in terms of land masses and being subducted and all of that, it doesn't really make sense. If you look at this is one of the key pieces of evidence. They started mapping the ocean floor from the mid-Atlantic ridge. They were doing this, I think, in the 1960s with these, sort of submarine things which were going down and looking at the mid-Atlantic fault line. And then they did all these surveys of these lines, and they're magnetized. The ore in them is magnetized, north and south, and then south and north. And so they're able to work out the oldest seafloor was about 180 million years in the mid-Atlantic ridge. So that's a bit of a problem, because that means that all the ocean floor has been created in the last 180 million years. But if the Earth is 4 billion years old, some of it should be well over that age, so that's the sort of fundamental part of the Earth expansion evidence from looking at the actual seafloor. I mean, we can see that the continents fit together, as I think we covered that last time, but this is a key piece of evidence. And we did talk about this in the email, and I would suggest, I'll go on. We'll go on to this with some of the later slides, which I didn't really show last time. But this brings us on to the question of where did the oceans come from? Because everyone agrees that there were all these shallow seas, in the ancient Earth. There were no deep oceans. So where did they come from? And of course, we suggest that they came from inside the Earth. Anyway, so I'll briefly go through some of this just in 2 or 3 minutes. 1858, people were sort of fitting the continents together. I showed a couple of slides from the book, or a couple of bits from the book last time. Then we went on to Wegener, who was talking about continental displacement, which was what their plate tectonics came from. It was renamed as continental drift because they didn't think it was a scientific theory, a valid scientific theory, so they renamed displacement to drift. Like drifting around with no aim is ridiculous. But it was S. Warren Carey. He took the plate tectonics theory originally as being correct, but then he continued to work on it, and he sort of took it forwards. And he then sort of was looking at the work of people like Otto Hilgenberg, who built these globes in 1933, showing that the continents fitted together quite nicely on a smaller globe. And then Warren Carey did that. I think I showed that last time in the book. And he found that if the Earth had a lower curvature, or more curvature rather, when it was smaller, because obviously the curvature is larger with a smaller object in terms of the same length of material, he found that the continents would be a better fit if it was a smaller globe. And then Klaus Vogel, he got in on the act sometime in the 60s or 70s, and he built this.
Sorry, can I just ask quickly, with how much of an increase in size do you think we're talking about? I mean, is it a couple of percent, or is it like a doubling?
It's a lot. It's like probably about 40%. I mean, you can see it in this picture here if you look carefully. You can see that the original Earth, I forget the exact radius. I've got some measurements in the book, but I think it's like about 3,700 kilometers radius, and it's now 6,720 around as the radius now. So it's about double what it was. Um,
Right. Okay.
and you
There's
can
a
work
bigger
that out
difference than I was thinking. Yeah.
yeah, you can work that out fairly precisely, and that's what James Maxlow's done. And going back to Carey, who's championed this, and there's a video of him actually I found not too long ago. It was made in 1980. There's a good video on YouTube of him talking about it. I was really glad to find that because I'd never really seen him. He died, I think, in about I don't know, late 90s, I think, or early 2000s. It must have been after year 2000. Then we talked about Neil Adams, and he did these computer animations, which are pretty good, very good actually, and you can clearly see, it's like that thing I showed you with the India
Yes.
thing, but
Yes.
done much higher quality, and it's done in 3D. He was doing, I think, digital animation back then, and he somehow got wind of this Earth expansion, and he got his computer guys to put this animation together.
Well, he's a very famous cartoonist, isn't he? He does all the...
Correct. But he doesn't want to know about the science. He never quotes James Maxlow. In fact, I discovered Neil Adams 2 or 3 years before I ever came across James Maxlow, who's actually did his PhD on Earth expansion.
Yes, it's dramatic. It's dramatically smaller, isn't it?
Yeah, it is. It's about half the size. Let's see. And then you find papers like this from Nature from 2002, secular variation of the Earth's gravitational harmonic J2 coefficient from Lagios on non-tidal acceleration of Earth rotation. A long title which I don't immediately understand myself.
Yeah, what does all that mean? Yeah, what's a J2 and things?
Our planet's waistline is mysteriously increasing. So there you are, and I think this article comes out with a figure of 14 millimeters a year of the rate of expansion. Maxlow had calculated about 22 millimeters, I think, in his calculations.
And is that still happening then? I thought it had stopped expanding.
Yeah, well, I mean, I remember it being on bloody Blue Peter when I was a kid, saying, they found that the continents are moving apart, and the US landmass is going to be 2 inches further from the UK by the year 2100 or something. I forget exactly. That was on Blue Peter, but they of course have claimed that this is what's happening is the Earth isn't expanding. The continents are moving apart, hence the idea of tectonics, plate tectonics and continental drift. But they claim that the Earth's size is fixed because the matter that's been coming out is getting subducted in places like the Mariana Trench, I think it is, and there's actually there's a continental plate going under oceanic plate, or the other way around. I can't remember which way around this is.
Well, I remember I remember the plate tectonics very clearly, but
right.
I just assumed America must be getting nearer to China on the other side until I saw your program.
Right.
But clearly that's not happening, is it? Can I just jump in with a couple of questions as well there? Because, well, I think we're going to come on to it, but I mean, Patrick was saying there's only a finite amount of water, and water's the big key, isn't it? This is what we're going to get on to, I think.
Right.
Where's all this extra water coming from, yeah.
Right. And then, so just skipping over a few things, we will get to that in a few slides' time. We'll start to get onto that. This was a different animation, a bit like what Neil Adams did, but it was completely independent. This was done by Stephen Hurrell, where he just sort of did it. He took away all the ocean floor, so he looked at that those mid-Atlantic ridges and how that had all spread out, and he basically just sort of undrew that. He took that out, and he came out with the same result. So if you simply just remove the ocean floor from the accepted diagrams, you'll get a smaller globe, and it all fits together. So he just did it a different way. And Maxlow came on the scene in the early 90s and did his PhD, and he's written 3 or 4 books on it now. The last one of which he sent me a copy of. And he's mapped out where the magnetic North Pole, it says 18 millimeters here on the slide rather than 14 millimeters, but Maxlow calculated 22 from his own research. So yeah, he came out with this his PhD, I think, in '96, and you can still read that. Actually, it's online. I think you still get the whole of the PhD from the university. It was published electronically by the university,
So he got his PhD, but this hasn't become widely
Yeah,
accepted, though, is it?
correct. I mean, there's a few scientists that do accept it, but it's one of these sort of fringe, regarded as fringe, but it has grown in interest over the last few years. And at that conference, I'll just go back a couple of slides. There was that conference in 2011 by this Italian guy. What's his name? Giancarlo Scalera. He's got a good set of papers on Earth expansion on his website, or it might be on ResearchGate.net. I can't remember where it is, but he's got a good collection of stuff. So Maxlow has mapped out all the geology, and it all fits. He's mapped out the fossil record, that all fits. Maps out the movement of the North Pole, that all fits. Because where the North Pole was, in terms of the landmass that it was on, has changed slightly, because the continents have moved around. So won't go on to that. So this is this idea of subduction, where you get the oceanic plate going under the continental plate and being destroyed and melting underneath. But this is a bit strange when you try and argue it, because this is actually, I think, lighter. So you've got a lighter thing being forced under a heavier thing, and it doesn't quite work when you look at it. And they claim the scientific claim for subduction being proved is that what happens is you've got this oceanic plate which has a certain type of material in it with an isotopic ratio. I forget. I've got this in the book as well. I forget which substance it is off the top of my head, but it's got a certain amount of iridium in it, or something like that. And then they've said that this has gone under, and then there's been a volcanic sort of vent here, and they've measured exactly the same isotopic ratio coming out of the lava, from the volcano or something. So they claim that this proves subduction, but that's one of the things that they claim proves it. I don't necessarily agree with that, because just because it's gone under it, there could have been some of the same rock in this plate for all we know. You'd have to see it before and after to actually prove it.
Yeah, well, also got another good question there, saying that if the world's getting bigger, then the water should get shallower, shouldn't it, logically?
No, not necessarily, because if you look at what's happening in some of the volcanic vents, water is coming out of them under the ocean. So water is coming out at the Mid-Atlantic Ridge all the time, and you can actually
I think
see
this
that.
is
There's a video of that.
Just give a bit of background for people who weren't watching the last one. The sort of at the bottom of all this model is this sort of almost a hollow Earth,
Right,
with it within the middle of it being water or steam, and then a layer of I could never remember the name of it. There's that special
slush,
pumice type slush, which is more fluid.
We call it
so
slush.
water actually comes from
ringwoodite. Yeah, ringwoodite. So the problem that we relate what got Stephen Hurrell interested in was the size of the dinosaurs, because we argue and he argues that the size of the dinosaurs being so large is related to the size of the Earth, in that we had a smaller globe and therefore gravity was different, and that allowed the dinosaurs to grow bigger. But you think, smaller globe, less mass, so
gravity should be less,
there. So gravity, but it doesn't work, because the force of gravity to the surface is Gm1m2 over d squared, right? So although the mass was less, the radius was less too, and the radius factor is more important because it's squared. So if you take half the mass with half the radius, the gravity is still more than it would be now, because the radius affects the force of gravity by a squared factor. Do you see what I mean?
I don't actually, because I thought if
you work it out the other way around.
So if we're talking then that if I was to take a point on a planet there, are we saying that the attraction is come from the far side of the planet? Is that what's attracting me? Because what I thought is as the Earth...
It's meant to all act from the centre, you see. So it's Gm1m2 over d squared.
But we're saying there's no mass in the centre, aren't we, if it's a hollow Earth?
No, we're not saying that, not quite.
Okay.
But if you work it out, it doesn't quite... The smaller Earth doesn't explain the increase in size of the dinosaurs, but directly.
This is the bit I have most trouble with. I don't think we'll go into it today, because we want to talk about the oceans.
It's all in my book.
Yeah, well, even the book as well. Trying to, well, let's not do it now. But why gravity goes down and not up, or,
right.
or
Well,
why it doesn't
go
increase.
To a completely different area of explanation. So
Yeah.
you've got some anomalies with the dinosaurs, like for example the Brontosaurus. How did it pump the blood up to its head when its neck was way above the ground? You know, they can't really explain that, because if you say that this force of gravity was the same with the dinosaurs as it is now, it would need an enormous heart. You know, 1.6 tons I think it is on this thing here. And you know, you get things like that, and then you get Meganeura, for example, and the flying dinosaurs. Argentavis is one of these giant dinosaur birds, for example. You know, and you can't say that these birds were just sort of floating on top of a swamp like the Brontosaurus were, so they didn't actually need strong legs, you know, to support them, because they were floating in water all the time. How did these giant birds and the Quetzalcoatlus, how did they fly? You know, if you look at the aerodynamics of them, they couldn't have flown. They could not have flown it with the force of gravity as it is now, because if you look at the length of the bones and the wing surface areas and that sort of thing, they would never have been able to fly. You know, and same with the insects as well, like the dragonflies. So we know for a fact that the force of gravity was different in the time of dinosaurs. It had to be, because you know it must have been. So you know that came into our discussion with Peter Woodhead and me.
Yeah, because you can't think of any. Sorry to interrupt you. I don't know if anyone out there. I mean, I can't think of any other way you can explain, like things being able to handle higher weights or fly if they're too heavy, without there being less gravity. I mean, so we don't spend too long on it now, but I know in your book and discussions you go through, you know, if the air was thicker or the air was thinner. All those things cancel out. They don't affect the overall flyability of something.
You're absolutely right. So there's one guy, I forget his name off the top of my head, and he's got this. It's called dinosaur theory or something, and he just states quite bluntly at the end that the density of the atmosphere must have been almost as thick as a liquid, and he says that's the only scientific explanation for the dinosaurs. And he says that is the correct explanation. End of story. But you know that's ridiculous, because you can't have a pterodactyl flying around in a liquid. You know, when you had an ichthyosaur,
you would have to swim, wouldn't it? Almost, yeah.
Right.
Yeah.
So you know, it's like he ignores. He's got a very good kind of logic to it, but then at the end he kind of just falls on his own sword, so to speak.
Well, I was also thinking that trying to move around in that kind of atmosphere would be more difficult, if anything.
Yeah, you know, you do the calculations, and it comes out with the atmosphere must have been like 7.5 times thicker than it is now, or something. I forget the figure he comes out with. It's all on his website. And did I write to him? I think I did write to him, but I just got a sort of stupid response back. I think it was so daft I didn't even bother putting it in the book, you know. But anyway, so then we come on to this idea of trying to explain how the Earth has expanded and where the oceans came from, which are the two sort of questions we were looking at, just going through quickly tonight. And this was really all came to me from Peter Woodhead, who's he's actually a builder. You know, he did A-level maths, so he's got a pretty good maths brain on him. And so all he was doing is things like volume calculations to see if this would stack up. And he basically said, let's see, yeah, we talked about that last time. I know. I'm just seeing I've got this other picture. Yeah. So he thought I'll go backwards and forwards. So it makes it a bit easier explaining it quickly now. So he came up with this observation from TW Hydra, one of these stars, where they said there was a snow line around this star. So it's basically implying that a certain distance out from the star, you got clouds of water floating around. But then when you get a certain distance out, you get snow because it's cooler, you know, and therefore you're going to get snow and ice forming there. So he basically said, well, what happens if the Earth wasn't like a fiery ball, but basically it was a large block of ice to which rocks accreted around the surface? That was his basic idea. Now he really just stuck it with that. He didn't sort of say, oh yeah, well they definitely showed that in the TW Hydra observations from the Atacama astronomers. But he just went with this idea that you've got an icy core surrounded by rock. What would happen? And then he suggested that basically what you get is you get this situation where you had an icy core surrounded by rock, and then within this rock you have radioactive isotopes, and within that would generate heat. So we don't really care whether it was a frozen core, or I think you brought this up last time, or whether it was just all liquid. It was liquid from the get-go, or more or less liquid.
Yeah, I'm thinking more of a snowball type thing, but it doesn't.
Yeah, that
doesn't
really
matter.
Matter to this idea, particularly whether it's solid ice or whether it's snow. Sort of not.
Or it's a bubble, even. I accept that. Yes.
Right. So, because what he points out is that the Earth expansion started 340 million years ago. Again, we're sort of going with this. I know you disagree with a lot of the timescales, but
well, different ideas. I wouldn't say disagree. Yeah.
Right.
Yeah.
Right. Okay. Well, maybe you'd argue with certain details, but we tend to go along with the standard timescale for the most part. So using the sort of standard figures, the Earth is meant to be about 4 billion years old, but the expansion started, according to the geological record, about 340 million years ago. So you basically got 3.5 billion years or so, where the Earth didn't change in size; it was just this fixed size. So we argue then that over that period of time, what was happening is the ice core was, or maybe it was just water. Either the ice core was melting, and then the melting water was brought to the boil, or it just took all that time for the water to boil, basically. And so then what happened was they started to boil. You get gases forming and stuff, and those gases all go to the centre because of this. This is where we brought in this experiment from the International Space Station. I think I've got the clip here. See if it comes up.
My favourite bit of video,
this
yes.
time, didn't we? Yeah. So we played this.
Yeah, I love this video.
And so you inject the air into it. So if you imagine that's the sort of core of the Earth, and then eventually the bubbles go to the centre, not on the outside, which is the opposite of what you'd expect. So that was the argument that we were making. And then you put tea leaves into it, I think, in this next bit, and they go onto the outside. So the heavier objects stay on the outside.
Yeah, if you haven't seen this before, this is in a vacuum on a NASA up on a space station or something.
On the ISS. I don't think it's a vacuum. It's just in the free space.
Oh, no, sorry, gravity. I meant not vacuum.
Yeah,
it's no gravity. That's what I meant. Yeah,
or microgravity, perhaps. Yeah.
It's spinning out of gravity. So when these particles of tea or something are put in.
Yeah, tea leaves. Yeah.
With the current model of the world, that should be our iron core in the centre, and they're clearly thrown out.
So it's the reverse. That's what we were arguing, basically. So yeah, there we go. That's a sort of larger version of that I've just said. And we heat by radioactive decay, so the water starts to boil. Then you've got telluric currents, because the Earth's going around the sun. And I know you talk a bit about the electric universe model and all of that. So the Earth is like it's a conductor in an electric field. So you're getting telluric currents induced in the Earth's rocks, in any sort of metallic ores and stuff. So that also contributes to the heating, we would argue. And you might have lightning storms doing a bit of heating on the surface perhaps as well, but that wouldn't be the main part of it. And so then you end up with this, whereby this is all sort of essentially ice, and then it goes to water and it starts expanding from then. Obviously there'll be a little bit of contraction first, because the ice is higher in volume than the same amount of water, isn't it? So the locking of the tetrahedral crystal, the way it locks when it freezes. So then over time, more and more water starts boiling, and you get this steam expansion because it expands by 1,600 times. And so you've got this, hard rock around being slowly penetrated by water. So you end up with what we would argue is what the structure of the Earth is now, and you've got some liquid water underneath the mantle, you've got maybe gas in the middle, and then we argue that the centre of mass force, or the centre of gravity, would be somewhere in the middle of the Earth's crust, not in the centre of the Earth. And that's where we start to get into some more complicated arguments that people sort of shot us down on that, but we think there's something in this, and I go into that in a bit more in the book. So that's the sort of proposed current structure that we have. And if you calculate the volume of, say, of this layer, Peter did some calculations, this sort of cyan blue layer, if you calculate the volume of that layer based on it being a certain percentage thickness, so say this is 6,000 miles here to the gas from the gas center to the Earth's crust is 6,370 kilometers. So that liquid layer might be, say, 800 miles, 900 miles thick, whatever it is. and then you calculate the volume.
Yeah, it's a lot of water, isn't it?
Yeah, it's a lot. And we worked out something like 40 times the volume of the oceans. Because we found the accepted figure for the oceans, which is something like, I don't know, 150 trillion litres or something. Again, the figures are in the book. I've put the calculations there if people want. So in other words, we at least did the calculations. Peter did the calculations to see if this was feasible in terms of just the volume. If it made sense just in terms of volume, and it does. It does stack up. Then we looked at Jan Lamprecht's work. He talked about hollow planets. I've read his book, but he gets obsessed with this polar hole here, which is not necessary. In fact, this polar hole would blow a hole in our idea of a gas-filled Earth, wouldn't it? Because it just shoots out of the poles. But then, you start to get onto the stories of the hollow Earth, and the hollow Earth stories are primarily driven by this idea of polar holes. They're not exclusively based on that. But if I try and go back a few slides, one of the other things that I go into in quite a bit of detail, because I heard this on like a Red Ice radio broadcast a few years ago. I'll just go back a few more slides. Let's see. You get these like polar hole images, but that's not what you think. That's a composite image. Let's see. I'll go back a few more slides. Yeah. So you go and look at this story, Olaf Janssen's story, which is it's a good read actually. It's a good yarn. It's a bit like Journey to the Centre of the Earth. The Smoky God, it's called. Some guy on Red Ice Radio, I forget who it was now, he was going on about this story, and he says he thought this book was a true story, and that's what convinced him that the Earth was hollow, because Olaf Janssen allegedly travelled into the inner Earth in this story, and he says he came out again. So I read this book. You read it in 3 hours. It's only about 40 A4 pages or something. It's a really entertaining story, and I enjoyed reading it. And they meet these giants and stuff, and I've taken some other plates from the book, and they have this fantastic technology and stuff, a monorail and all of this. And then what happened was they stayed in the inner Earth for about 2 years or something, or a year, and then they went in the North Pole and came out of the South Pole, and there's a disaster, and Olaf Janssen's father, who was with him throughout this journey, is killed, and Olaf Janssen is left on his own, sitting on an iceberg. And then this Scottish whaler called the Arlington, which was captained by Angus MacPherson, finds him in the middle of the Antarctic Ocean and picks him up, and then he gets back to Oslo, according to the story. So I thought, we know the dates. He says that it was June 1829, sorry. So he gives a date in when this story supposedly happened. We know that he was in the inner Earth, according to the story, for 2 years or something, or 18 months. So he came out of the inner Earth in 1831. So I went and checked to see if we could find a record of the ship, the Scotch whaler, called the Arlington, in
Good
about
thinking,
1831. Yes. And I got in touch with this guy called Malcolm. Malcolm Archibald was his name, and he's one of these guys that he just looked into the history of Scottish shipping, and Scottish whaling and that, whale hunters. I probably just looked it up on Google search, and he says that he said he didn't think this ship existed. There were no whalers in the Antarctic from Dundee at that period of time, so that I couldn't corroborate this story from any historical record. And I checked a few other details. The journey looks plausible. If you read the book and you look at where he said he went to Franz Josef Land, and they sailed up the coast of Norway and stuff. If you look at that part of the book and map it all out, which I did on this, and I mapped it all out on Google Earth, and you see there that this journey in the book is about 10 weeks, and they sailed 3,500 miles if you measure this on Google Maps.
Okay, yeah,
3,500 miles. So you can argue that 50 miles a day in that sort of boat that they were in, that's okay. You can do 50 miles a day in it. It's quite a modest speed. So the journey looks feasible. And that part did seem to stack up. from the story.
But it's the rescue that doesn't, yeah?
The rescue that doesn't, and then they're supposed to have landed on this island. If you can see this red line, I think there was meant to have been this island somewhere near here, which doesn't exist. So if there was an island there, there's no trace of it now.
I thought he got picked up in the Southern Ocean. I thought he came through the Antarctic.
That's right, he did. But as on the way out, he says that they went to Franz Josef Land, which I think is Spitsbergen here. I think I haven't labelled it on this figure, but this is Franz Josef Land, which I think belongs to Denmark now. And then he says they went from there and they sailed for another 4 days or 5 days or something, and then they hit another island and they picked up some driftwood there for, for fuel or something.
Right.
Making a fire or something. But that island doesn't exist, so I couldn't trace that island in the story.
Okay.
Let's see. So then, you get onto these stories of polar holes, and then you start to get onto the Admiral Byrd story and all of that. But it just doesn't stack up. So I'm going to go back to go. So I couldn't find any evidence, any credible evidence of polar holes. Basically, there wasn't any evidence of it. And then Michael Palin, for example, he went and did his pole to pole trip. And he couldn't find any holes. He didn't talk about any holes. There's a big base at the South Pole. He's been there. There's no polar holes there.
Well, this is a question I want to ask you. I mean, are they actually going to the poles? Because I know with the South Pole, they seem to quite often just go a couple hundred miles from the coast, don't they? It seems.
No, I mean he went to the south. He went to the actual South Pole. I mean, you can tell that from a compass. You can tell it from a GPS tracker. He didn't not go to the South Pole. If you watch the Pole to Pole documentary, he said yes, there are two South Poles. There's a ceremonial pole and the real physical pole. And they're like, I don't know, a couple of 100 meters apart. And he went to both of them. And the Americans didn't want them to land there. I got that clip in my video of this, and that's why it got blocked on YouTube, because I'd used a clip from Pole to Pole, and it got blocked on YouTube because I'd used that. And the Americans didn't want them to land. They said, we haven't granted you permission to land, but they said, well, we've got to land anyway. It's got to refuel to go back.
No choice.
They took their own camp, and they weren't allowed to camp in the American base or stay in the American base. I was trying to get this other thing up.
So where do all these stories come from? And so you say there is a bit of footage of Palin with his compass kind of going crazy.
Yeah, he walked around the South Pole. I don't know if he has a compass. In fact, maybe he does have a compass. I'm not sure, but I just want to go back to this. So I didn't find any evidence of the polar holes or anything like that. So then we get to, let's see. I've got to go backwards and forwards. But I've got to go forwards now to where I was. Let's go. Jan Lamprecht. Yeah, so it's he estimated that our oceans currently hold a volume of 135 billion kilometres cubed of water. That I got from an estimate, and we calculated that the ice core could melt and it would come out. And this was the thing that I was telling you about. I didn't manage to show you this slide though last time. So when I posted this interview with Peter Woodhead, where we talked about this idea of having slush, water, a slush layer in between the ice and water, on the very day that I posted it on YouTube, it was 12th of June 2014, this story came out in New Scientist, massive ocean discovered towards Earth's core, So what better kind of, vindication could you have for that? And actually I found that this is one of those stories which actually came out at least 7 years earlier. There was another story that I found after this one, which came out in 2007, which was basically saying the same thing, although I don't think they'd found the Ringwood Eye. And then, we discovered a corroboration elsewhere in the solar system. Hubble discovers water vapor venting from Jupiter's moon Europa, which has got on under the crust ocean, and that's pretty well known about now. And then Enceladus has got the same. This has got vents of water coming out of it from the surface of Enceladus, which is one of the moons of Saturn. So that's got an under the surface ocean as well. And I discovered this as well a few years back now, but I just found the slide. Saturn's moon Titan has a very salty ocean. And so there you are. It seems to be a common thing. We had Mimas. I think Mimas has got an undersea oceans. There's a couple of other bodies that have got them as well. So, we argue that this is the correct explanation, that there is all of the water of the oceans has come from inside the Earth, and it could have come out in bursts as well, and that would explain why, if the Earth is expanding and the water is coming out slowly through the mid-Atlantic fault line, that's why the ocean stays full, because if it wasn't coming out continually, then as the planet expands, the ocean levels would drop, wouldn't they, if there's no extra water coming out?
So well, this is the thing, isn't it? I mean, are we going to finally end up with a water planet or something? Or, and the other question, of course, is when
well. That's we may already have the answer to this question, as Peter and I sort of more or less alluded to. You look at what's happened to Jupiter. What's on the outside of Jupiter? What's it called? It's called a gas giant. What happens to water when it goes into space? It becomes gas or vapor, doesn't it? So the Earth might end up as a gas giant if it sort of slowly breaks apart, and then all this fluids kind of comes out and sort of forms around it. Then we could just might end up like Jupiter or Neptune. Maybe
go into water
like
world.
Yeah. Maybe they were like the Earth originally, or maybe they just accelerated to that size more quickly because they were originally larger than the Earth. But they were originally more like the Earth is now, and then they expanded. That would be, and in fact, we actually found later. And I put this in the book. I'll see if I can find this. I'll just quickly Google this so you can see. It does tie into what I'm saying.
So go backtrack slightly, because a lot of people are commenting about these. So you don't hold much truck with these stories that you can't fly over the poles, or that on Google Earth and that you can't see the poles.
You can't. In fact, let me go back, because I was contacted. If people are asking that question, I'll take that opportunity to go back.
So it's definitely a folklore I've heard, that you can't fly over the South Pole.
That's not correct.
Oh, right, okay.
Because, I'll tell you for why, because I got to know a commercial pilot, and he was called Don Daniels. There we go.
Don's plane, I can see,
Don Daniels, yeah.
Back a couple, yeah.
So
right.
That's it. So I wrote to him, a North Pole no-fly zone. Well, if you can't see the hole from the satellite, then you can't see it from a plane, can you? So I wrote to my friend Don Daniels, who knew I'd flown planes for United Airlines at one time. I asked him if you could fly over the North Pole. He wrote, "We are not allowed to fly directly over the North Pole, the stated reason being that the older navigation systems, for instance on the B747, would get temporarily confused as to which south reference to reference to. Newer navigation systems, like on the B777, mathematically switch the poles to the equator when we are far north or south, and there is no ambiguity. However, they tell us not even to even ask, as we will not get permission to deviate directly over the pole, or it would be considered a gross navigation error. I have been within 60 miles of the North Pole on a number of occasions, and while it is surprisingly smoggy or hazy, I should have been able to see an opening of any significant size." And again, people have been there on the ice mass to, film wildlife or look for things on the ice sheet, and Michael Palin's been to the South Pole. So, that's good enough evidence for me. They say there are no satellite pictures. That's what that was the view that Don sent me, that he got out of the plane. Sort of inconclusive from that angle. But again, you go and look at the other satellite pictures, and you can find satellite pictures of the pole. That is a lie, that there aren't any. There are less of them, I think, because the polar orbit is more difficult to achieve in terms of fuel. You need more fuel, and you have to be more careful if you're going into a polar orbit. So you wouldn't really want to do a polar orbit except for scientific research, because you don't really need one except for scientific research, really, particularly. And people say, "Oh, Operation High Jump. Oh, yeah, Admiral Byrd. He encountered aliens. He encountered this Nazi fleet or something that shot his planes down." I don't think those stories are true. I think they've been exaggerated from Operation High Jump. Did they find something unusual? Maybe. But I think all this started up again, and I found the reason for this, and I put this in the book, because I think it was in the late 90s, Admiral Byrd's diaries were published for the first time, and they found, if you read it into his history, he's the only, he was the first person to fly over both poles, I think, at different times. He had an expedition to the Antarctic 1928 to 1930, and he had a flight to the North Pole in 1926. But if you read his diaries, there is some doubt that he actually reached the North Pole, because he had an oil leak, and he thought that he actually turned back, about 2 hours before he was due to fly over it, so he could get back, because he would have run out of oil and crashed in that time. And that only came out, you see, in his diaries in the 1990s. So I think these stories about him, encountering strange creatures, or going to this land where there was green and animals and stuff at the South Pole, this warm area,
or a Nazi war fleet.
Yeah, and you heard various versions of this, of Nazi war fleet, Nazi secret base. All that came out around about when his diaries were made public. And I don't know exactly why, but Dennis Crenshaw has a good write-up of that on his website.
Didn't he do a lot of TV interviews and high-profile stuff back in the 50s? So I thought...
Some, yeah, he did some. There were various things that he was involved with, though. I think there was this giant ice thing as well, ice sort of mobile that he was involved with as well. But this story of him actually encountering beings appeared to have come from the script for Lost Horizon, which was a movie. If you look at the original source of this story, with Admiral Byrd meeting these beings, and you read the dialogue that is meant to have been said to him, this actually seems to have come from this Lost Horizon film. And
what year was the film, do you think?
The film was 1930s, I think.
Oh, right, okay, so that's definitely first then.
Yeah, I think it was like 1936 or something. But I've put all this in the book, so I'm pretty convinced that there may have been secret things that Byrd discovered, but the Hollow Earth wasn't one of them, and the polar holes wasn't one of them, I'm pretty convinced that that's correct.
Okay, well, that's what we're trying to get to the bottom of, yeah.
And you can find that. I think if you keep looking for it. It took me a while to find it. It took me fair few hours of research to sort of uncover it all and piece it all together.
Because the question I was going to ask was if there's these holes in the tops and the bottom, what keeps the water in? That was the
exactly.
That was going to be the next question. Yeah.
Yeah. So the holes aren't there basically, and the only holes are ones that. And this is not to say there may be a subterranean civilization, and for example, there may be undersea bases, the flying saucers and stuff. And I was reading Timothy Good's book, Alien Enterprise, 2013, and that's got some quite interesting accounts of this race of beings which allegedly established undersea bases, quite big ones, and some people actually were taken, as in confidence into them by this group of aliens, and I couldn't. Those stories to me sounded plausible. I couldn't see any reason for immediately dismissing them, because if they're deep under the ocean, you're just not going to know they're there, because the oceans are so vast, and most of us live on the land and never even go.
Yep.
We go paddling on the beach, but what else do we do?
And the oceans are very big as well, yeah.
That's right. Okay, we go across on the ferry. Did we ever go in a submarine? Maybe once in a lifetime. How far do you go? Maybe a few feet. If you're a submariner, yeah, you go down thousands of feet. Have you got any windows there? No.
Nope.
So you're not going to see anything. Do satellites look much under the ocean? Well, okay, we've got some interesting Google Earth images now, haven't we, of the seas, and people pointing out these anomalies.
Yeah, but the vast is unmonitored, isn't it? Yeah.
Right. And these stories of this this oasis of green and stuff. Yeah, those are correct, because there's this place called Bunger's Hills, which was discovered on Admiral Byrd's mission, and they found a freshwater lake on Antarctica, and the temperature, I think, was 34 Fahrenheit. In other words, 2 degrees above freezing, and that's
just
in
enough.
Antarctica. Yeah, so it's just enough, just above freezing. So I think that's where some of these stories of this land where it was warm came from. Yeah, it is a bit warm there, and there's also a volcano on Ross Island as well. Let's see, I can't remember why I put this slide in. Yeah, so that's where Bunger's Hills is. So you can see it's an ice-free region. It's quite big as well. In Antarctica, there is an ice-free region. Yes, that part's true. So I'm not debunking that. So right in the middle of an Antarctica, maybe not right in the middle, but there is an ice-free region. That's true, and that is true that Admiral Byrd's group discovered that area. They called it after the pilot who was flying it. So that part's true. So in other words, it's like all good stories. There's a bit of truth in there, and then it's blown out of proportion, or it's twisted, or embellished too much. Or aliens get involved or something. And so that is basically the story, as I understand it, of Admiral Byrd.
Do you think Admiral Byrd was part of that story then? Do you think he was he fed the story, or was it all done after his time?
I don't know. I think it was probably done after his death. Some of it feeds into the stories of At the Earth's Core and the Doug McClure films, that I remember enjoying as a kid in the 70s. But Land That Time Forgot and The People That Time Forgot.
Great film, that one, yeah.
Yeah, I love that film. Me and my mate used to love seeing that at the cinema.
I remember that one.
Crappy special effects, but it was an
who cares
film,
about that? Yes,
that's right.
It's called suspension of disbelief, isn't it? It hasn't got to be perfect. Yeah.
And then going back to the gas-filled Earth theory, this sort of again ties in with what Jan Lamprecht. He points out that if you look at the way they measure seismic waves travelling through the Earth, this does support the hollow Earth idea, or as we say, the gas-filled.
Yeah, I like this one. Yeah.
Different. So that stacks up, but then Lamprecht goes off the rails as far as I'm concerned with the polar holes, and he spends a whole chapter talking about polar holes, and all this and the rest of it. But that's, to me, is just a distraction. It wouldn't work. It would detract from this, in fact. So we agree with him on that, and I put that in the book as well.
Sorry, could you show the last slide again, just quickly?
That one?
No, the one you keep jumping through, the one that says Admiral Byrd near the top of it. Yes.
Yeah. So if you look at some of the things, and I've read some of these are still on the internet. There are no satellite pictures involved. That's false. You can find them. Admiral stories, Byrd stories are misquoted. The land that he supposedly discovered, this warm land, was probably Bunger's Hill, and it was actually based on that. Olaf Janssen's story, I can't say it's totally false, but I think important details which should be verifiable, really, you can't.
That's the sort of sailor's tale from the 1820s or something, wasn't it?
Yeah, kind of. And again, it's sort of, if you look at the time when it was written, and you look at the Jules Verne stories that were going around, and I don't think H.G. Wells had quite got going by then.
A little bit early for him, but there was a lot of that kind of adventure stuff, wasn't it?
Yeah, it was like your Jules.
I guess Robinson Crusoe wouldn't have been far off then.
Robinson Crusoe type stories, it was of that ilk, to me, and I think it's, if you look at it in that context, it makes more sense. But I'm still not putting my hand on my heart and saying it's an untrue story, but I just can't find the evidence to verify the details which make it really interesting.
As your website is called, we're checking the evidence, aren't we?
Yeah. Like I said, the journey itself, if you look at how it's described, it looks valid. It looks like you could have done it, and it was a doable journey and whatnot. But he might
a well-researched story, but nonetheless more like to be a story. Yeah.
Yeah, probably a story. Yeah. So that was basically a quick sort of run through of and the interesting thing for me in going through all of that was that I sort of originally put that Hollow Earth story together, and I debunked the Hollow Earth. I said no, it isn't hollow, and the Earth is expanding. I agreed with that part, but it isn't hollow. So I was kind of left with Maxlow's explanation, which is all this matter being, because Maxlow, you see, if you read his ideas, he thinks that matter is being created inside the Earth, and then there's some process, some cosmic process or something.
Yes.
And he has pictures of this in his book. Don't get me wrong. He tries to explain it, but again, he doesn't have any evidence because we haven't, and he can't have any evidence because we haven't been to the centre of the Earth, and of course we haven't either. Maxlow hasn't, we haven't. But we just think that our ideas, we've got some evidence from the solar system which seems to suggest that it's correct. We've got the idea that water comes out of volcanoes. Our idea, or Peter's idea, explains the origin of the oceans pretty well, really. You don't need any
Well,
fancy explanation to.
Yeah, one of the things I like about the way you work these things out and the way you operate generally, and I've read a few of your books now, and it is what I was talking about on my Sunday broadcast was this idea of false dichotomy you quite often get, or conflation, whereby I can sort of if there's two theories, and I can just prove something wrong in that theory, therefore I prove this one, and it's just not, and that's done all the time in science. So what you've done here, you found holes with this theory, but it doesn't mean the theory's wrong. It just means different bits of it might be. Or
no, that's it. You can have a theory, and I think the best sort of science is where you do actually do like a Lego operation of theories. You'll look at one theory, look at another theory, take the bricks from each, and build them into what is something that's a third theory, or if you want to call it that, or a synthesis, and that's actually closer to the truth than either of the other two. Really, to me, that's the way that science should work, isn't it? That you're using the work of others in a respectful way to try and get something closer to what's actually the real truth. And of course,
as opposed to this seems to be an awful lot of stuff is done by false dichotomies. You just prove a hole in that theory, therefore you prove this one.
Yeah. And again, you've got to be careful not to throw the baby out with the bathwater.
Yes, which is the other side of it then, which is what you haven't done here. It's like, okay, we haven't got the holes, but we might still have the rest of it, perhaps.
That's right. And, so some people would say that even talking about the hollow earth is just a crazy sort of fantasy. But actually it's not. And in doing that, you see, I was very glad I did it. Because that it was originally Peter that saw my original presentation, which just had the expanding Earth and the hollow Earth in it, not the gas-filled stuff. And Peter added the gas-filled stuff. And then classic build on top of that was when Frederick Nygaard came in, and he'd been looking at the electric universe stuff, which of course ties back to Velikovsky.
Yes.
Velikovsky, of course, he was. I haven't put it in this presentation, but in the book, it was Velikovsky that was pointing out, for example, why the ocean's salty. Where does the salt in the oceans come from?
Sorry, very sorry. There's a bit quite. Velikovsky did what? Sorry.
He was asking where the salt in the oceans came from.
Oh right, the salt. Right. Yes. Okay.
We did touch on this last time, I think, where all rivers are fresh water. The rivers flow in the oceans. So did the rivers create the oceans? Did all the ocean water come out of river flow? No. We know that the rivers aren't salty, else we wouldn't have freshwater fish, would we? There's a fairly clear line of demarcation between freshwater and saltwater. So we argue that the saltiness is from salt domes, which are large geological structures, sort of deep down in the Earth's crust. Not that deep down, but maybe
I know what you mean.
Meters down. And I think Velikovsky talked a little bit about that as well. So that again ties it together. And then, as I say, Frederick Nygaard, he came in with explaining the gravity, which was to do with the capacitance of the Earth as a sphere, and if it increases in capacitance, electrical capacitance, it increases in the force of gravity, because there's this sort of tie-in between electricity and gravity, which again is what Wal Thornhill was talking about.
And then we go down a whole new rabbit hole, then, don't we? Because it's the whole idea of gravity has changed because the Earth. That just might be incidental, might be. Something else has caused the gravity to change. All we know is that gravity's changed at the moment, isn't it?
Yeah.
But I mean, this puzzle we got, this mathematical. I'm sure you. My maths isn't good enough, but I mean to try and work it out. To me, I'm still trying to get my head around the idea that it gets bigger and the gravity gets less. Yes, that's right. No, the other way around. It gets more. Sorry. But maybe then the capacitance increases. Maybe there's other factors. We don't really understand gravity, but do we? That's my point.
No, that's right. But I just wanted to point out one other thing which came up, and this I think came to me from Frederick Nygaard. So I'll just go back to the screen share. Where am I going now? Just onto here. I'll show you this quick article because I wanted to show you this earlier because I didn't put this in the PowerPoint. And you were asking me the question, well, or maybe one of your listeners was saying, well, so the Earth's now expanding and the water is coming out of the centre, and I pointed out that. We may become like a gas giant. Jupiter and Saturn and Uranus and Neptune may have been more like the Earth, hundreds of millions, billions of years ago, whatever figure you want to put on it. And then you see here, May 2018. This is actually Frederick's blog, a lovely looking blog that somebody did for him as well. And you'll see that the Juno mission to Jupiter, they released some measurements. I think this is the link here. Yeah, this is from Nature. It says in here that Jupiter has a large and diffuse core. So what's a large and diffuse core? Well, a diffuse core isn't really a core, is it? You know, a core is something that's compressed and, you know, sort of, sort of bunched together. But if
a gas is diffuse, isn't it?
Yeah, if it's a diffuse core, it means it's hollow. So, you know, this we again interpreted as support for the idea that Jupiter has, it's probably got a remnants of a gas-filled core. It's not a solid rocky core. There's something like some shell there perhaps or something, which would be what the Earth would turn into based on our theory. So again, this came out I think 3-4 years after. I don't know if that's. Let's just see if Jupiter has a large diffuse core. There was another NASA story on that actually, but I don't seem to have got. I thought that was the link, but. So let's just see if I've got it on here as well. So we would argue that this supported Peter Woodhead's idea of gas-filled planets and expansion.
Could apply to all of them and the moons as well, isn't it?
Yeah. Yeah. Or maybe that was the original article. I just haven't read down to it. So we think that's good evidence to support that the Earth is actually got a gas-filled core, and probably the other planets too. We looked at the moon and stuff and did a little bit on the moon, and that we think is what drives the expansion.
All right, cool. So can I just ask one thing before we wrap up? Have you heard the story about it's come up in our chat during the week about the moon ringing?
Yes.
Like a bomb went off or something, or
right. So there's this idea, yes, that apparently the Apollo missions that which didn't land there, they left a seismometer there, and this picks up impressions from when meteorites, land. And I think maybe when they did this L-Cross mission, where they had a rocket booster from Mars, from the reconnaissance orbit, lunar reconnaissance orbit is what I'm trying to think. I think it was the booster section of that probe. They crashed that into the surface and then measured the seismic response. And apparently, one or other of these events is said to have rung like a bell, suggesting that the moon is hollow as well. Now, of course, there's various theories about the origin of the moon. Some people think there was that book by Christopher Knight and who's the other guy?
Yes, the moon is a mystery, isn't it? Because it doesn't fit with the rotational energy and stuff, does it? There's lots of problems with it.
I haven't looked at that actually, Ross. That's an interesting one.
Oh yeah.
In relation to the size of the Earth and the Moon, it's the biggest satellite in terms of the fraction of the parent planet in the solar system. The Moon is much bigger in relation to the planet it's going around than anywhere else. So that's very unusual. Of course, we've got the unusual thing of the solar eclipse, where the sun is 400 times further away, but the moon is 400 times nearer for the most part. Obviously, we get annular eclipses and stuff like that.
And the rotations, so it's always the same side facing. There's all sorts
right.
of...
Well, that they claim is explainable with the tidal locking, and there's models for that. And I'm reasonably comfortable that would work.
Yeah, I've always felt it probably should always face the same side, but I'm not sure it's always the same with other...
Oh, it is. I mean, there's several other examples in the solar system that are the same. I think Iapetus is one. I think, and you can just look up tidal locking, and you'll find a list of satellites that are tidally locked to their parent planet. Not everyone is, but I think there's a fair number.
Okay.
I forget off the top of my head. And
I didn't have such a big issue with that one myself either. No,
Peter and I discussed whether if the moon was filled with water as well, that might actually help the tidal locking, because if it's spinning at a certain speed and then you've got this fluid inside of it, it's actually, there's like a friction effect inside, and that slows down the rotation. And if it's fluid filled, it's more likely to become tidally locked than if it wasn't. If it was a more This, we
Yeah,
made that argument.
yeah.
We didn't really go into all the science of it and all the fluid dynamics and stuff like that because we're not that clever.
But what I think it gets interesting is that if you look at the various theories where if the moon has come from the Earth somehow, we've got two ways of it coming, haven't we? It's either come from the Earth or it's an independent object. It's either come from within the system or from outside the system. You have three options. And the problems with the ones where people say it's broken off the Earth are that the rotational energy, the mass doesn't work, because it doesn't go far. But if both objects are hollow, they're a lot lighter than we think they are, then maybe that rotational model would work. It's the solid masses that doesn't make it work.
Right, and that going back to that,
it could be like a great big drop of water coming off rather than a great big chunk broken off.
Right, there's various scenarios that you can think of, but one of the problems which we do have with the theory is the mass. We did talk about the mass issue, not tonight, of course, but Peter and I did, and that was one of the things which was more difficult because we were arguing that, of course, it was a gas-filled core or it was water-filled, but in that case, that gives the measurement of the mass of the Earth a problem because
it'd be dramatically less, yeah.
Because the density, yeah, because like iron is like, I forget what specific gravity is, but I think it's like 15 times, more dense than water or something. So we would have a problem there, but we sort of played a bit with that one and suggested that, well, if the mass of the Earth is wrong, then maybe all the rest of the mass in the solar system has been overestimated. And I think we estimated that the actual mass of the Earth might be 10% of what the real, the agreed figure is. And then we pointed out that if you go with that and sort of extrapolate, that gets rid of this idea of the dark matter. You don't need to have dark matter.
Right, because you got rid of 90% of the required mass.
90% of the universe is meant to be dark matter, isn't it?
That is clever, yes.
So we made that argument.
I like that.
It wasn't particularly scientific.
No, it's a back the envelope job, isn't it? This could explain why there's not enough mass, yeah.
So that would need a lot more work to see where that went. But we've already started to challenge what causes the force of gravity. So they use the force of gravity to measure the mass, don't they, and vice versa. They're interrelated in physics.
Well, the problem with all these things, they're a mathematical model, aren't they? This is the problem.
A lot of them are, yeah. Some of them obviously you can measure on the desktop, so you get a bit more convinced that at least in the local environment they're correct. If you have two weights and you put them on a weighing scale and one gives half the reading of the other, you can be pretty much sure that there's half as much material there, can't you?
Yeah, but all the mathematics of long distance gravity, should we say, is only based on maths, isn't it? We don't really know the distances and we don't know the masses. If they're a lot lighter, maybe they're nearer. We could be.
Yeah, so once you start to go beyond the Earth, does mass and matter and gravity behave the same way? Does it follow the laws? I mean, okay, we've got probes that have been.
Oh, we're into a big subject there, aren't we? Because even things like distances away from the moon and stuff is all worked out mathematically based on gravity.
To an extent, I mean, some of it's now based on laser ranging and things like that. So there is some sort of separate verification, and I think you have to sort of remember that we do have, for example, geosynchronous satellites which do things. So some of the science has got to be mathematically correct, else we wouldn't be able to walk out of the house and watch our movements on a map on our phones,
yes.
etc., or use our sat-navs. We know that works. We know it's not magic. We know that it's technology, and we can prove that it works by our own actions, and our own independent actions.
Yeah, we don't know how much calibration's gone on or anything like that, do we? I mean,
no. But I mean, what I'm saying is that we can't just throw. A lot of these. I get a lot of these flat earthers writing to me. You see, and I just tell them to go and study some more science.
Well, there might be other explanations. I've got any no skin in this game. I'm just throwing up opportunities.
Well, I think everyone's got some skin in it because
our whole bodies in it.
Everyone has got some skin in it, at least, because everyone can observe things
yes.
in front of their faces. And I mean, as I say to people, anyone can get a bike that's reasonably able-bodied and two sticks and measure the sun's shadow with a piece of string and a protractor on the ground at certain times of day. and that's all that you need to do to prove the shape of the Earth, because that's what Eratosthenes did.
Yeah.
Was 5,000
Well,
BC.
I don't think that proves anything, does it? I think
it does. It does. It proves it from geometry. It proves it from geometry. If you have a circle on a piece of paper that you can make measurements of, a ratio that comes out as pi, for example.
You can also make it work other ways. If you have two sticks and you have a small light moving around, you can achieve the same thing.
No.
I think it was Einstein. Einstein said you can't. There's no way of proving the Earth's shape without leaving the Earth.
That's a misquote. He wouldn't have said that. That's a misquote. You can prove it, and it was proved years ago. You can prove it. And anyone that says that you can't is lying. And they need their head examined.
That's okay.
I've encountered those people, right, and they've lied to me. So I know that at least some of them are liars, because they've lied about how they've interacted with me. That's, so you've got to be careful here. You've got to be careful that you're not so open-minded that your brains fall out. That's a.
I know Carl Sagan quote. Yeah, but
to me. And yes, of course, we know there are people like Carl Sagan who are gatekeepers, but again, you don't, just because Carl Sagan is a gatekeeper, for example, and he actually worked on a secret program to set a nuclear bomb off on the moon in 1959, way before he was doing the Cosmos series. Not a lot of people know that, because that document only came out. That doesn't mean to say that everything that Carl Sagan said was false, So he actually said some good stuff and some interesting stuff, and so he did make some good points about science. So again, you've got to be careful what you go along with and what you can measure, and you should never immediately accept a YouTube video of your own eyes and ears and observations that you can make, and pen and paper calculations that you can make yourself if you learn how to do them. You've got to learn certain things. If you don't understand geometry, then why don't you spend whatever length of time it takes to understand it properly and empower yourself? And when I talk to some people, they don't know the difference between a statute mile and a nautical mile. And they don't know the reason for that. That's a fundamental thing that you should be able to work out for yourself with some simple drawings on a piece of paper, if you know what you're doing and if you're guided, if you don't understand. That's what happened to me. When I was in school, I learned geometry, maths, physics, trig to enough of a level that I can prove certain things. I can measure a distance on a map myself and prove that it matches with another distance that's given to me. Things like that. And it's not.
Well, I have a maths and stats degree as well. Yeah, so.
Well, there you are. So you
and physics A level. Yeah.
Things. You can prove certain things, and in the you see, it's a bit weird, because in the science world, it's unfashionable to look at fringe topics, but in the fringe world, some people assume that all of science is wrong. All of it. It's all a lie. So everything is a lie. People will say that. So you've got to be careful that you don't just end up in one camp or the other and throw out the bits of truth which are available in each side. You've got to be careful about that.
Oh, I totally agree. Yeah, I also think there's sometimes more than one theory can appear to work in the same situation.
Yeah,
that's what I'm saying.
I agree. Yeah, that's absolutely true. So you got to be wary of that as well.
Excellent.
But, yeah.
Maybe I've got past 10 o'clock now, haven't we? So
yeah, I better get off.
I'm sorry about that, mate.
No, that's all right. No, it's fine.
I normally have everything ready to go, and it's usually pretty good. But
not a problem. No, I understand.
As I came rushing, I haven't even shaved. I hate being unshaven as well. Look at that. So there we go.
That's all right.
I like to care. Well, it's very nice to see you again. Thank you very much, and thank you very much for clearing up a lot of the stuff with the holes at the top and the bottom.
No problem. Yeah.
And I appreciate your approach on this kind of thing, because one of the things people are concerned about is when we start looking at hollow earths and various other theories, that we lose credibility then of the stuff that we do know better. I would say the history and the stuff that's been researched, and
absolutely,
you got to be careful you don't lose credibility on some things. It's nice to have someone who comes along who knows the science well and can show that actually this bit does stand up or whatever.
So I'll just finish that.
Yes, please do. Yes,
I've been talking about, and that's available as a free PDF download. If you did want a physical copy, you can get them either from my website or on Amazon. I will mention that there are two versions of
and I put a link in the description. Yeah, and I should be ordering one of these as well.
Okay.
Yes.
Yeah.
Oh, I have to say, just one thing before I forget. I was trying to put a direct link to which book, the Outlaw Bird book. I couldn't find it listed under your books or anything on the website. So
well, it's in this one.
I've seen that one. Okay.
Bird store in it. Yeah, it's got all the stuff we had tonight and a bit more,
okay.
fair bit more stuff as well. But what I was going to say is that there are two versions of this. There's a black and white version in print and a colour version, because the colour version is a bit more expensive to get printed, obviously in small numbers. It's quite a thin book. This, I think it's only like 150 pages or something, so it's not a thick book. But you can download it in PDF, and of course that's colour from the website for free. It's all in there. And I've tried to put everything in a logical order.
Yes, it's very good.
I hope that people consider it and see what they think. And
no, I think it's wonderful. You make so much stuff available free as well. So, not that there's anything wrong with people buying this stuff as well. You can buy books, make a few quid for you.
No, I mean, to me, it's, as I might have said last time, it's a happy medium. Some people like electronic versions. Some people say, I need a physical copy. So, okay, you want a physical copy, you've got to pay for it, because I can't really afford to give those away free, and I make a couple of quid on each one, so I'm happy,
Excellent.
Yeah.
All right, well, thank you very much indeed. And
all right, then.
Sorry it's a late finish.
No, that's all right, Ross, and we'll talk again, I'm sure.
We will, yeah. Not on a Tuesday, though. Rugby training's back on, so I have to avoid Tuesdays.
We'll make it another day next time, then. Yeah, I understand.
Excellent. Well, thank you very much, and thank you for everyone who's stayed with us watching.
Absolutely.
Really appreciate it for everybody.
Yeah.
And
thanks for the questions.
Thank you again, yeah. And we'll see you again soon. And from me, good night.
Hedwig.
Yeah. I do my dragon, Hedwig.
Bye for now.
Bye-bye.
Bye.
There we go. Oh, I better not end the meeting for everyone, because I'm going to be... I need to work out how to stop this now. I've got three things open.
I can't shoot any of us, so we'll
okay, yeah. I'll just stop everything. So thank you, everyone. And we got a hello, Ross. Hello. Thank you very much. And I got so many comments, I can't keep up with everything. So the Science Illusion by Robert. I think I can see some people aren't in a rush to go. I know Andrew had to go, and it's getting a bit late for me. I'll just read some of the comments before we finish. So you have to look at the side of my head a bit. Hang on, I can move the. And for those, I think there was a comment there asking about my little cat there. Who's a very pretty thing. Aren't you pretty? Yes. Well, that's a bit of a scary look. You want to go to sleep, do you? You ready to go to bed? So there we go. Isn't that the prettiest cat you've ever seen, eh? That's Mimi, which is a very creative name, which is Mandarin for cat. And the other cat we had was the Japanese for cat. But that wasn't us. That was one of the neighbours. They called the cat Japanese. We got the Chinese name. So there you go. You're bursting my brain tonight. Yeah, I think my brain's a bit bursting after all that as well. Physics, maths, black holes. Yeah, we'll be back to history soon. And one of the things about the channel I was thinking as well, and I do a lot more on the Wilson and Blackett stuff, because one of the things, while I was watching all the rugby training, because I sat through 2 hours of it, was there's so many good little stories in things like Arturius Rex discovered, which I'm going to be covering in little short videos. And if you want to suggest another chat for next week, I'm quite up for it. Maybe next Wednesday, not Tuesday. But other topics, I could, because we've got Robert Langdon's coming on soon. And we're going to be discussing there more about, do you remember Robert? He's the one who does the canals, the dikes becoming canals. And another topic came off the back of that. Oh, yeah, I remember. With Marcel as well, hopefully, about was Troy in Cambridgeshire in southeast England rather than in Anatolia, or were there two Troys? Because Robert Langdon's got a theory that Troy was actually out in Doggerland rather than in Cambridge. And someone else on the group, John, new to the group, I don't know his name off the top of my head yet, he found another article where he showed not far from where Marcel had put Troy, there's another place in Cambridgeshire, so near Gog and Magog. Alright, so yeah, the flood, I didn't get onto the flood. I want to talk about the flood, because if you've got all this water inside the earth, there's plenty of volume of water to come whooshing out. Because if you look at the old Assyrian information, as far as I understand it, when they talk about the Great Flood, they don't just talk about endless rain, they talk about water coming from below and above, which is a bit weird. And this sort of earth being filled with water or steam, and then this layer of slush, which we didn't get on too much tonight, producing all that water would be a possible explanation. Because one of the things that's always troubled me is when you look at great flood stories, or myths as they call it, I hate that word, because myths to me always imply something is not true or not based on any truth. But these old, I would say I prefer stories, great flood stories, like the Bible, Great Flood, and all over the world you got flood stories. So is it a case of there were loads of localized floods and they've all got a flood story, or was there one big flood in one particular area, such as would be implied with the Bible, and then people migrated? Or, which is the theory I'd like to look into more, was there indeed a flood which covered the whole world? Because the argument against that has always been there's not enough water around to flood the whole world. But if the earth is water inside, then you can do it that way. So just some things for people to think about. And do we have any, not relevant if you don't buy NASA? Yeah, I wouldn't buy with a NASA. I'd like to have another look at that, by the way, what we were talking about with Andrew there. I think you can show it different ways with 2 poles and Melistosthenes, whatever his name was. Right, anyway, I think my children are still up, 10:15. Well, it is holidays. It is holidays. Right, we can hear noises. I'm going to put those to bed. So I'm going to pull this together now. So thank you very much, everybody. Hope you enjoyed that. Oh, and now I shall just end the show now. I'm going to hear... I can just troll on my microphone cable as well. So good night from me, and I'm going to do a good night from Mimi. Alright, okay. Most uncooperative cat. Mimi, come on. Yeah, I know, you're going to be nice to everyone, alright? I know you hate there we are. The least tactile cat I've ever had, unless it's at night, wants to sleep on my face. But in the day, you're a very independent little cat, aren't you? You don't want to sit on my lap. Look, you're happy there, okay? She can have her own... She has that chair, I have this chair. How weird is that? You have your own chair. Look, she's quite happy sitting over there. There we are. Oh, she's gone now, after saying that. Thanks a lot. Never work with children or animals, and I work with both really all the time. So thank you very much for your patience. I'm going to edit out the first hour and just run the second hour. And I've got loads more stuff to come up. And the Britain's Hidden Christianity book coming out. Almost finished. And thank you for your help on that, Marshall and Patricia. So, yeah, thank you for anyone who made it to the end. I've no idea what the viewers are. But until the next time, from me, North Star, if I can work out to close this down, Hedwch. No idea. End. If that's just going to end this bit, that's not a help. I got it.